All right, so first thing, we did this last time, but just to make sure we're good. And these are going to look the same, but we're going to label the angles, so hopefully you'll see that they're not exactly the same. So let's say this one is a 45, 45, 90. And let's say this one, we'll pretend this is 30, 60, 90. Trust my angle measure's not what it looks like necessarily. All right, both of these are going to have a hypotenuse of 1. I want you to find what the other sides are going to be. And yes, rationalize. All right, guys, chat with your neighbor. Is it the same? Do you guys have the same? Rationalize. All right, guys, trying to get something to print here. All right, guys, so the 45, 45, 90, what did you get for your legs? Root 2 over 2. Yes. Is everybody okay with that for both legs? The special right triangles from last time, that's stuff that needs to stay in your brain, okay? And then the 30, 60, 90, how long is the short leg if your hypotenuse is 1? All right, that one's easy. What about the long leg? Okay. These numbers are going to basically be tattooed in your brain from this point forward, okay? They are everywhere on your unit circle, along with 0. These are the only numbers used on your circle for ordered pairs, okay? So just be aware, but this is where they all come from. It all originates from those special right triangles. We aren't just like making up numbers on your unit circle, okay? Question here? Yes. Yep. Yeah, Mom. So remember our formula, hypotenuse equals root 2 times a leg, right? So if my hypotenuse is 1, I would divide by root 2 and then rationalize. Yeah, you see it? Okay. Yep. Any other questions on that before we actually jump into the circle, Myra? So long leg is always root 3 times the short leg. So root 3 times a half is root 3 over 2. Don't make it more complicated than it is, okay? Just multiply straight across. Okay, I'm going to give you a blank unit circle just so that it's nice and organized for you as we go through all of the pieces. While we're filling this out, if you have different colored pencils or pens, you might want to use those. I think it really helps if you color code it so you can see where everything comes from. see the connection. Guys, this really isn't just like, let me stare at it and memorize it. Like, it all comes from an understanding of how these things are connected. So if you can see how it all works, it's so much easier than trying to just straight memorize it. All right, guys, I'm going to start in red, but it does not matter what color you guys start in. We're going to start with just the X and Y axis because you know a lot of those things already, okay? I know this is 0 degrees, and we're going to do degrees first because that's right now what you're more comfortable with. Won't always be that. So that is 0 degrees right over there. How many degrees is it up at the top? 90. Okay, right. Right angle up there. What about all the way over on the left? 180. Down at the bottom? Okay, good. We can add. And then all the way back around your circle? Okay. That all makes sense, right? We know there's 360 degrees in a circle. We're just going by 90 degrees in each quadrant. Okay. I'm going to switch colors on you. I'll go blue next. So 90 degrees to get all the way up to the top. What if I want to go halfway into that first quadrant? How many degrees is that? 45, yeah. So the middle one here is 45. I'll wait a second too. I hear lots of people digging for colors, so hold on. So all of the middle lines or points in these quadrants are connected. So that one's 45, 90 is at the top. What do you think is in the middle in the second quadrant? 135. Good, 135. Again, stick with that blue color. Then we come down here into the third quadrant. What do you think? Good, 225. And then the fourth quadrant, 315. Good. All right. I'll go greenish next. All right, we talked about the special right triangles. We've dealt with the 45-degree one now. So the other special right triangle is 30, 60, right? I'm going to do, let's do 30. That's obviously going to come before 45, right? So this is the 30-degree angle. All right, you guys see how that's closest to the x-axis, okay? So all of the points like this that are closest to the x-axis are going to be connected. So that's 30 degrees away from the x-axis. What do you think the degree will be in the second quadrant? Not 120. That would be up here, which is not where we're talking. 150. I want these, I'll try to put green dots on them so you can see them. I want the ones closest to the x-axis. So this is 150. You guys see what I'm talking about? Okay. What do you think in the third quadrant? 210. Good. 210. We're doing one at a time here. Only the green ones. Fourth quadrant. What am I going to put?
330.
330. Good. All right. I'll go purple for my last color here. So the points that are left are the ones closest to the y-axis, if you will. You can't see the bottom one there. What angle do I have left to work with? 60. Okay, so this is 60 degrees in the first quadrant. What is it going to be in the second quadrant? 120. What about down in the third quadrant? Good. Fourth quadrant. Okay, we have all the degrees in our unit circle. I'll let you make sure everybody's got all of them, okay? Now with the degrees, there's a lot of symmetry going on here in your unit circle, okay? These are always going to be 30 degrees away from the axis. Same right here, 30 degrees away. And then how many degrees is it in between each of these? Yeah, so you can like count your way around the circle. You're going 30 plus 15 plus 15 plus 30 plus 30 plus 15 plus 15 plus 30. Okay. So there's just a pattern there with the degrees. But again, it does all come from your special right triangle. Okay. All right. We're going to do radians next. So I'll go back to red. Starting over on the right there, 0 degrees, that's the same as 0 radians. Okay, 0 pi radians. Just put another 0. Now last class we talked about 180 degrees. What is that in terms of radians? Pi. So over on the left here is pi. So what is it going to be up there at 90 degrees? Pi over 2, right? It's halfway there. What about down at the bottom? Okay. And then if you make it all the way around the circle, 2 pi. Charlotte, do you need me to rewrite something? I just the bottom, it's 3 pi over 2. It's like 1.5 pi. Yep. Switch into blue next. All right. 90 degrees was pi over 2. What is 45 degrees going to be? Pi over 4. Okay, so I'm going to put pi over 4. All right, every single one of these blue points on my little circle here is something over 4. They're all connected. They all have the same denominator. Something over 4. Now, could you do the conversion for every single angle on here? Yes, but that sounds kind of miserable, right? I don't want to convert every single degree to radian. I just don't want to. So I'm going to show you how it works just with fractions. This is 1 pi over 4, right? 2 pi over 4, but it reduces. Okay, so this is going to be 3 pi over 4. You're literally counting along the numerator. If it reduces, you're not using it. If it doesn't reduce, it's something on your circle. So 1 over 4, that was there. The next over 4 we need is 3 pi over 4. Yeah. It's just pi over 2. So this one's 3 pi over 4. So then I count along. Do I want 4 pi over 4? No, because that's just pi. What about 5 pi over 4? Yes. Do I want 6 pi over 4? Nope. So what's my last one? Okay. Do you guys see that pattern there? Okay. All right, I'm going purple next. Or did I do green? I think I did green. Okay, do you guys know what 30 degrees is in radians? Okay, good. That means all of my green ones, the ones closest to the x-axis, are something over 6. Okay, so we're going to count again. We were at 1 pi over 6. Do I want 2 pi over 6? 3 pi over 6? 4 pi over 6? 5 pi over 6? Yes, that's the one that doesn't reduce, right? Okay, so that's 5 pi over 6. And you can also think, just with your understanding of fractions, I'm 5/6 of the way to pi, right? Like I'm pretty close to being all the way to pi. That's also what's happening there. Keep going. Do I want 6 pi over 6? Nope. What am I going to use? Okay, and then what's the last one going to be? Good, 11 pi over 6. All right, on to purple. What is 60 degrees in radians? 3. Yeah, pi over 3. It's a third of the way there. Okay, so they're all over 3s. All right, good. Pi over 3, 1 pi over 3. Do I want 2 pi over 3? Yeah, it doesn't reduce. It's the next one. This is 2 pi over 3. What's the third quadrant one going to be? Good. 4 pi over 3. And the fourth quadrant. Good. Okay, you have all of your radians now. Do you see it, how it's just patterns and it's not that bad? It's not this crazy thing to memorize right there. You're just thinking through your fractions. All right, we have ordered pairs left. Going back to red. Okay, it is the unit circle, meaning the radius is 1 unit long. So this point over here at 0 degrees, what would the ordered pair for that point be? 1, 0, right? We went over 1, up and down, nothing. So 1, 0. So what is that going to make the point of that 90 degrees? Yeah, 0, 1. At 180? Okay. Down at 270? And we're already back to pi. Okay. So those aren't too bad. Okay, what we're looking at, we're going to start on the blue one again here, 45 degree. If I were to draw in a little central angle triangle here, like if I were to draw this down to the x-axis, all right, you see that right triangle? Don't draw this on your paper. The hypotenuse is 1, and it's a 45, 45, 90. Oh dear. It disappears. I'm using a pen that disappears. But we did it right before we started our unit circle. What are the sides of that triangle? Okay. Yes, root 2 over 2. Think about if we have, so this is your central angle of 45 degrees and your hypotenuse is 1. Remember we did this right as we started? It's in your notes, yes? Okay. This is the x side. This is the y side. Your coordinate for that point is the ordered pair of the x and the y. Okay? So that's what we label it as. Maybe get back there. So this is root 2 over 2, root 2 over 2. As you go in the second quadrant, what's the only thing that's going to change? Yeah, the signs. You've just got to pay attention to what's negative. So if I'm in the second quadrant, what is negative, my x or y? Yeah, so it's going to be negative root 2 over 2, root 2 over 2. What about in the third quadrant? Both negative, yeah. So negative root 2 over 2, negative root 2 over 2. And in the fourth quadrant, the y, yeah. So root 2 over 2, negative root 2 over 2. Questions on the blue ones? If you know the first quadrant, you know all of the quadrants, okay? Just being aware of the signs. All right. I'm going to draw the triangle in here for the 30-degree one. Don't draw it on your paper because it just makes it really messy. So this is the right triangle I'm talking about, with a 30-degree angle there. The x part of that triangle, is that the long leg or the short leg?
Short. The long.
The x part.
Long.
Isn't this longer than this? Yeah? Okay. So your x coordinate is going to be bigger than your y coordinate. It's a 30, 60, 90 triangle with a hypotenuse of 1. What is the long leg? And what's the short leg? Okay, so that's the x and the y. Let's get my triangle up. Root 3 over 2. Do you now know the second, third, and fourth quadrant green coordinates? Yeah, the x is negative over here, so negative root 3 over 2, 1/2. Third quadrant, they're both negative. Negative root 3 over 2, negative 1/2. Fourth quadrant, you'd have positive root 3 over 2, negative 1/2. Yeah, we're going to do one in just a few minutes. Yeah. All right, guys, all we have left is the purple ones, the 60 degrees. So 30, 60, 90, 60, 30, 90, it's all the same numbers, right? They're just in a different spot. So if I look at this triangle drawn in, the horizontal piece, the x part, is that now the short leg or the long leg? Okay, horizontal is sideways. Which do you think this looks short or long compared? Like, this is short, guys. Okay, this is a smaller length than this. Yeah, that's your short leg. So your ordered pair now is just 1/2 root 3 over 2. So it's the same numbers, but in a different order because it's the x that is now the short leg and the y is long. And then again, once you know that, you know all of your quadrants. Third quadrant, you have negative 1/2, negative root 3 over 2. 1/2, negative root 3 over 2. All right, guys, that is your unit circle. The idea here is to understand it, okay? It's not just, let me find some weird trick counting, 1, 2, 3, 1, 3, 2, 1. Like, no, just like understand where it all comes from, okay? Yes, you do have to be able to write out all of these things, but I hope you're memorizing it in a way of understanding it, not just like, let me spew it out at you without realizing where anything comes from, okay? If you know the first quadrant, you know the entire circle. Okay, you obviously haven't practiced this much. It's very fresh in your head, though. We're going to just see how much you already know. So I'm going to give you a 5-minute timer. I want you to flip it over. There's a blank one there. And you're going to try. This is practice, guys, of course. Yep. Sure. So I got to start here. Go. See what you know. Probably know a lot more than you realize. Fill in everything you can. All right, guys, your 5 minutes is up. So look, either flip it over and check yours, or you can look up here and just double check. Sorry, guys. Move that out of the way. Do you know almost all of it already? Yeah. How many of you are like, I got it all already? Okay, nice. How many of you are like, I'm real close? Okay, that's good. And if you're not there, that's okay. You have time to practice and study and all of that. But I hope it makes sense. Like, that's the whole point, is that you understand where these pieces come from, and you aren't just looking at it going like, well, there's just a whole bunch of stuff written on a circle. Okay? Like, try to understand where it comes from. And if you have questions, please let me know. Yeah? Like how I got the first quadrant one? Yeah, so 30 degrees. In my head, I'm just going, well, like, I'm doing a quick conversion in my head on one of them, because I know 3 goes into 18 6 times, so I know that's pi over 6. Like 60 degrees, I know, well, 6 goes into 18 3 times, so that one's pi over 3. And once you know those first quadrant ones, like, the others are going to be over 6. I don't expect you to be going, okay, 240 degrees, like, please don't be doing that. Yeah. You can just do the pi over 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Like, you just know from there. You know everything else. Yep.
Why are radians useful?
So what we're going to do is a whole bunch of evaluating trig functions, and it's actually easier to see the positives and negatives with the radians than it is degrees. Like right now, I'm sure you think I'm crazy when I say you're going to like radians more than degrees at the end. You absolutely are going to like radians more than degrees at the end, because the pattern repeats. So like when we go to graph sine, which we will eventually, we label our x-axis in radians. And I'm like, okay, I know this is going to be pi over 4, pi over 2, 3 pi over 4. Like, there's a symmetric pattern that happens there, instead of me going, okay, 45 degrees, 90 degrees, 135, 250, like, it's actually slower in degrees once you understand the radians. Right now, they're very new, but once you get comfortable with them, you'll be like, oh, that's easy. And if I had said, like, you're going to travel around the circle, 4 times and end up over here, you can easily go, okay, it's over 4, and like count your way around. In degrees, you'd be like 360 plus 30. It's just like this huge number then. Okay? So you will like them better, I promise. Okay, we have a little bit more to do in the notes. Time to go. Yeah. Yeah, all of these come from a hypotenuse of 1. Because it's the unit circle, that means the radius is 1. So like if I draw in, this triangle, this radius right here is 1. This is 60 degrees. So short leg, long leg, hypotenuse, like it's all based off of that. Okay? Like the ordered pairs?
Yeah.
So the only numbers you're using are from the, let's see, it was back here. Is that like, you've got, oh, not erase, right? That's all the 45 degree ones, or the over 4s. That's it. So if it's a 45 degree, they match. Hopefully these are easy to remember. And then short leg, long leg, just thinking about which it is, okay? But there's never going to be different numbers. You're not going to have like, oh, and now I have root 5 over 2. Like, nope. It's always root 2 over 2, 1/2 root 3 over 2. So on the unit circle, the radius will always be 1. We'll get to some evaluating later and some triangle stuff where you have a different radius. And that's fine. You then just go through Pythagorean theorem or other things to find those links. Yep. But if it is something from the unit circle, if it's one of these special angles, it is this. Like, the hypotenuse is 1. Okay? All right. We got to do a little more. We got to talk about how we use this unit circle then. So, this is continuing your notes, guys. Back to your own paper here. All right, so we're going to talk about sine of theta, cosine of theta, and tangent of theta. All right, that's a little bit of an extreme reaction there. I'm not graphing anything. I've graphed nothing yet. We're not graphing today, guys, okay?
So for graphing, should we like do
Yeah, I have a blank one posted on Schoology for you. You can just print. And like this is literally the quiz I'll be giving you next week.
We literally just have to fill it out.
Yes, like you now have the answer key to your quiz. Yes. Not next class, it'll be next week. Probably for you guys on Thursday. I think I'll do it after your retake. Yeah, so we won't do it on Tuesday. So Thursday for you guys, okay? All right, guys, so what we're looking at here is a little triangle in a circle. And I'm putting my theta right in there. That's just representing the angle. Mark, you with me? You put it away. All right. In this circle, does everyone agree that that little segment there is the radius? Right? Is that the radius of the circle? Okay, that's a little r there. And down here, would you agree that side is x? And that side is y? Horizontal piece is x, vertical is y? Okay. All right, dig in your brains back to sine, cosine, and tangent from geometry. Do you guys remember SOHCAHTOA? It's like, oh. We got to dig deep, guys. All right, SOHCAHTOA, sine is opposite over hypotenuse. R for radius. You have to be able to spell that right for it to actually matter, so. So if I'm saying the sine of theta, right? Here's theta. What is opposite of theta? Your choices are x, y, and r. Y, and what's the hypotenuse? Okay, so sine of theta is y over r. What do you think the cosine of theta is then? X over r. And the tangent of theta? Y over x. Opposite over adjacent, yep. Yeah.
Not on like the inverse of these.
The reciprocal?
Yeah.
Yes. We're going to do cosecant of theta, secant of theta, and cotangent of theta. Now are those fairly new to you guys? Are you like, what are those words?
No, those are the inverses.
They're not the inverses.
No, it's like it's to the power of -1.
It's the reciprocal.
So 1 over.
Guys, it's just the reciprocal. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. If you're struggling with like, which one goes with which, you should never have cos together, okay? Like cosine is not going to be matched with a cos something else. Yeah, Melissa? CSC is cosecant and then of theta. Yeah.
What's the difference between saying inverse and reciprocal? Like, I don't.
Inverse is switching x and y, solving for y, reflected across the line, y equals x. reciprocal. Middle one is secant, S-E-C-A-N-T. I'll write them above.
What is the abbreviation of secant and cosecant? Like, why wouldn't even CSE?
I don't know. It just isn't. I didn't make them up. So they're the reciprocals. So since sine was y over r, cosecant is just r over y. That's all you're doing. You're just flipping whatever the sine, cosine, or tangent was. So secant is going to be r over x. Cotangent will be x over y. Now let's think about this in the unit circle. What is r? Right, and what is it in the unit circle? 1. Okay, so with what we're dealing with right now with the unit circle, sine of theta would just be y. Cosine of theta would just be x. Okay? It's technically still y over r and x over r, but when r is 1, it makes it a little bit easier. The others would be, 1 over y, 1 over x, but that is important. All right, guys, so let's look at how we're actually going to use these. I'm going to ask you to evaluate different trig values around the circle. I'm going to say find the sine of 3 pi over 2. Now, for right now, definitely keep your unit circle out so you can reference this, okay? Eventually, you want to get to the point where you don't need that. Obviously, it's very new. You need it today, okay? So you need to find 3 pi over 2 on your circle. Where is 3 pi over 2? Where is it, guys? Where's 3 pi over 2? Bottom, right? Bottom is 3 pi over 2. I'm asking you for the sine of that. When we're in the unit circle, the sine is just the y value. So what's the y value for the coordinate at 3 pi over 2? There you go. We're done with that one. Cosine is the x value. Yeah. So let's do a cosine. Cosine of 5 pi over 4. All right, which quadrant has 5 pi over 4? Third, right? I always make a little sketch if you need to. Okay, there's where 5 pi over 4 is. Am I looking at the x or the y for cosine? X. What is the x part of that coordinate? There you go. We're done with that one. That's it. Right. But this is a huge part of what you're going to have to do. Yeah.
Do we actually have to solve it like for example, like x over r and y over r?
So in another section, we'll get to problems where I'll be like, your ordered pair is, 3, 2. You have to draw the triangle, evaluate sine, cosine, tangent, all of that from there. But that's it. what we're doing right now, all unit circle, that's your focus. Yeah. All right, let's try again. Okay, we're going to do cosecant. Let me walk you through how we do cosecant. And we're going to do it of a negative angle. Ooh. Negative pi over 6. Okay. Sine, cosine, or tangent. Which one is cosecant connected to? Sine. So I would first do this as sine of negative pi over 6. Negative pi over 6. What quadrant is negative pi over 6 in? Fourth quadrant. Positive pi over 6 is in the first. Where would negative pi over 6? Do you see it going backwards that same distance? It's down here. This is where negative pi over 6 would be. Coterminal angles from last time, remember? Negative pi over 6, that's the same as 11 pi over 6. Okay? You got to be comfortable going both ways on the circle, guys. So, sine, do I want the x or the y?
Y.
Okay, what is the y there? The y? Negative 1/2, yes. So what do I do to that to make it cosecant? You flip it. What's negative 1/2 flipped? Negative 2.
I'm confused.
11 pi over 6.
Isn't the Y value at negative?
Nope. It's negative 1/2. Look at your pi over 6. What do you have?
No, but the pi over 6. Yeah, the pi over 6 has 1/2 is the Y value.
Right. So all the over 6s should have 1/2 as a y value. You just have to decide if they're positive or negative. So, yes, like, you can also just look at your circle. Here's pi over 6, right? It's the first one in the first quadrant. So I need to go that distance backwards. So where am I going to end up? Okay. It's all, like, symmetric and everything. Okay. Are you okay? You're good.
What if you're like negative 13 pi over 6? Would you just go all the way back down until it would be the same?
Yeah, you'd be going, okay, over 6. So here would be negative pi over 6, negative 5 pi over 6, negative 7 pi over 6, negative 11 pi over 6. Ah, there we go, negative 13 pi over 6. We just keep going. Good. There we go. Or maybe. Oh, I have it on the other. Hold on. Maybe I wrote it wrong. No, it's right there. Because think about it, your x is long and your y is short. Okay. All right, guys, let's keep trying a few more of these. All right, let's do tangent of pi over 2. All right, guys. Where's pi over 2? Yeah, right at the top, right? Okay. What is tangent in terms of x, y, r, all of that stuff? Y over x. Okay, so the ordered pair up there is 0, 1. So if I do y over x, what do I get? Okay, I got 1 over 0. Is that okay? Okay, what am I going to write? Good, undefined.
Does that mean that for the x-axis, these points are like if you do that for pi over 2
For tangent, yes. For cotangent, no.
Yeah.
Okay.
And then for cotangent, it would be that x.
Yeah, Myra? Oh.
So for the unit circle is x and y over
On the x and y axis. But on the unit circle, it's this, like, this is x, this is y, this is x, this is y, this is x. Like, those are ordered pairs. X, y, right? What is the radius in a unit circle? What did we say? Anybody help her out? What's a radius in a unit circle? This is important. I want to make sure. It's 1. That's why it's called a unit circle. It's 1 unit for the radius, which is why we did these triangles with a radius of 1. In a unit circle, yes. All right, let's try again. Yeah.
So if y was 0 and x was 1, would the answer be 0? Or would it still be undefined?
Nope, it'd be 0. 0 divided by 1 is 0. 1 divided by 0 is undefined. Yep. All right, guys, let's try secant of 7 pi over 6. What is secant related to? Cosine. So do cosine of 7 pi over 6. Then do the reciprocal. I'll give you guys a second to try that. So guys, 7 pi over 6, that's down here in the third quadrant. Your ordered pair is negative root 3 over 2, negative 1/2. With it being cosine, do I want the x or the y? Okay, so the cosine is negative root 3 over 2. That means the secant is negative 2 over root 3. Rationalized, that is negative 2 root 3 over 3.
You always want to mention.
I do. And you're going to, you just haven't done enough to see it yet. You're going to have 2 root 3 over 3. You're going to have root 2. Like when you rationalize, it's the same stuff all the time. You're not going to continually rationalize. You'll be like, oh, I know that's this. Like you'll get comfortable with the numbers. Okay? All right, let's try another one. Let's do cotangent of 2 pi over 3. What'd you guys get? Got what? Anybody, an answer? Root 3 over 3 or just root 3? It's negative root 3 over 3. Let me walk you through it in case we're stuck. So 2 pi over 3, that's in the second quadrant. Your ordered pair is negative 1/2 root 3 over 2. We have to do x over y. That's negative 1/2 over root 3 over 2. That's negative 1/2 times 2 over root 3. So negative 1 over root 3. When you rationalize that, that is negative root 3 over 3. Okay? All right, guys, that is where we're stopping with notes. We're going to keep practicing these over and over. We will eventually have timed trig quizzes on these where you'll have to do like 10 of those in 100 seconds. Like, yes. Obviously not today, okay? But just know, like, you will get so comfortable with these values that you can do that, okay? All right, guys. There is homework in math space. I'm going to give you back your test. Remember, there's a 10-point bump of what you see on here. Yeah, see you. Yeah, the math quiz. Yeah. Did I get everybody?
Let's go.
What did I do? I was like, no, I got
Yeah. You got the rest of it? Forgot to
let's go. And this one, or plus
See, basically, yeah, just forgot to put white off the entire
I forgot the white. Yeah. Oh, yeah. Yeah, it's solving inequalities. Here, I'll do it up here because I think probably multiple people would like to see it. We've got time for it, okay? Hey guys. Nice stuff.